So how do you find the slope at just one point? I mean, if you had 2 points, it makes sense. It's pretty easy. You can draw a line between them. You got 2 points, x1 and x2, and you can calculate the slope, right? You got rise, delta y over run, delta x, and we all know that this is just going to be, y2 minus y1 over x2 minus x1. We can figure that out pretty easily, right? But what if we just have one point? 1 point. What are we supposed to do with just 1 point? I mean, we can't really use y2 minus y1. There's just 1 point, right? At this point, we actually have to use the derivative. All right, so now we can start saying something like this: dy over dx. What that really means is basically we're going to take the limit, let's put this in parentheses, take the limit as x2 approaches x1. So as x2 gets closer and closer to x1 until they become just 1 point. So close, in fact, that x2 minus x1 is approximately 0, right? x2 minus x1 is approximately 0. All right? If we get that, then we have dy over dx. This is going to be our instantaneous whatever it is, the instantaneous derivative at that point, the instantaneous change, okay? Over here, this would be the average change over a certain period of time, right? This is an average change from here to there. And from that is just the instantaneous change at that 1 point. There's 2 ways to write this. We got this particular way, which is simple. You might see like an a instead of an x1, okay? But over here, there's another way. We could also say that the limit, let's sort of rewrite this over here. So instead of y, we're going to write f of x, and then we're going to add an h on that one. And over here, we just got the regular old f of x. And then on the bottom, we got the x1, which is x plus h, or x2 really, and then x1 over here, which is just the regular x. Obviously, the x is going to cancel out here. It's just going to be an h on the bottom, but just to sort of visually see how this is the same thing rewritten. The limit as x approaches 0 is another way to write our derivative. These 2 things are essentially the same thing. So that's what the derivative is mathematically.